Hi, my name is Chris Woodward, and I'm a developer relations engineer at ArangoDB. And thanks for joining me for this lunch and learn session. Before we begin, imagine for a moment that you finally get some time to watch a movie. The popcorn is popped, lights are off, and you have your avocado onesie on. And now to find that perfect movie to watch. Well, this is where things could start to fall apart. The night could quickly turn into needing to scour the web to find that movie with the best Rotten Tomato score or read reviews across many different review sites. But this could all be avoided if your favorite movie streaming service had implemented a powerful recommendation engine. That's why in this Lunch and Learn session, we'll show you an example of using machine learning with graph databases to offer great recommendations, all from the cloud. The newly available Oasis example provides not only a graph dataset, but also a functional demo site we call ArangoFlix. All of this is directly available through your Oasis dashboard in the Examples tab. To get started, head to one of the deployments and then the Examples tab. Look for the example titled ArangoFlix and click Install. Once the example is installed, you'll see a new Demo button appear. If you click it, you'll be brought to the ArangoFlix website, where you could explore the movie data that has already been loaded into your cloud database. There is also a guide you can follow that will expand on the information we cover in this video. You can copy the root password and open your newly created database by clicking the Deployment button in the top right of the guide. Once you log in, you should see a database name that starts with ArangoFlix and then an underscore, followed by random characters that are generated. This database will stay here for as long as you wish. If you ever do decide you no longer want the database, you can simply remove it as you would normally remove any other database, or uninstall it by using the Uninstall button back in the Examples tab. To access this demo, you do need an ArangoDB Oasis account. If you don't already have one, you can sign up at cloud.arangodb.com for a free 14-day trial, and a link will be available in the description. To start out, let's talk about the approach we used to implement the machine learning inferences with our graph database. Then we'll take a look at some example AQL queries and how we implemented them with our Fox GraphQL endpoint, and finally the ArangoFlix website. For this demo, our goal is not to crown any recommendation as the best, but to instead show the many different approaches available and show how they can all enrich your graph traversals and provide the best recommendations possible. The techniques used here are also applicable to more than just movie recommendations, but we find it is an easy to understand topic with freely available datasets. We implemented 5 different techniques for offering recommendations. Content-based using AQL and built-in ArangoSearch TF-IDF, as well as collaborative filtering using AQL, content-based machine learning, which we implemented with the TF-IDF and FIAS algorithms, and matrix factorization, as well as graph neural networks. If you'd like to see the details of how all of the various inferences were generated, be sure to check out the resources section of the ArangoFlix site, as it links to helpful articles on the various techniques and the actual notebooks used to generate these recommendations. Once we had the inferences, we stored them along an edge, connecting the users and movies or movies to movies, depending on the technique. And these edges also contain the similarity metric generated from the machine learning task. This is usually a distance property or a similarity metric. If you explore the data through the web UI, you'll notice multiple edge collections. And this is because we use 5 different methods, resulting in edge collections for most of the techniques. While this may not be something that you normally would see whenever you're doing your own machine learning tasks, for this example, because we wanted to show off all the different methods, it resulted in more edge collections. Because this information lives on the edge, it makes doing AQL graph traversals easy, and it makes implementing the scores and the distance metrics from our machine learning experiments natural whenever we're doing a traversal. All of the AQL queries that we use to offer recommendations are available directly in the ArangoFlix UI as well. You can choose whichever method that you're interested in, and then from there, you can actually copy the AQL query we used right from the UI. If you copy this and paste it into your query viewer, you're going to get a view similar to this, where you'll need to supply a user ID, and this can be any user from the user collection, as well as the recommendation limit. This is the number of movies that will actually be returned. Executing this returns movies as well as their score and distance metric. The score metric is typically used as a way to determine how to sort the movies and is sort of a naturalized version of the distance metric. And as we take a look at this query, you can see that we've started out with getting all the movies that the user has rated. This is an important step because we don't want to return movies that the user has already seen. That doesn't make for a really great recommendation. And then finally, we start doing a graph traversal where we start from that movie or that person, depending on the technique, and then we find similar users or movies and return those results. And as you see, the last part of our step here is doing some sorting so that our results are already pre-sorted for us so that we can offer the most relevant results to the user in the UI without having to do any sort of client-side logic. All of these queries are implemented using a GraphQL Fox service that's also bundled with the database once it's installed. You can check out some example queries for the GraphQL service, such as this one that we use to return the graph neural network recommendations. While on the front side, you're always putting in a GraphQL query, this is all supported using the AQL queries that I just showed. If you'd like to play around more, this GraphQL service is available with the database once you install it, and you can access example GET and POST requests here. You can also directly download this Fox service and explore the actual code that we use to implement it by going here and clicking the download button. While you're in the web UI, be sure to also check out the graph viewer. We have a number of different graphs that help describe the information available here, as well as an ontology that shows the relations of the movie and actors. Now that we've taken a look at the various pieces involved with creating the recommendation engine, the machine learning experiments, the notebooks, and how we generated the inferences that we use in our graph traversal, as well as the AQL queries that we're actually using to serve these recommendations to our GraphQL Fox service. The front end is the final piece, or the avocado on top, that consumes that GraphQL endpoint and actually presents these things to the user. You can explore this fully functional website to learn more about all of the various recommendations that we're using, the AQL queries, and a little bit more information on just the techniques itself. And you can actually get some information on the movies. This offers real descriptions for the movies, and you can see the things such as the movie description, the genre, as well as the language. And you can sort by these things as well. So if we want to get horror movies, we can search down to there, or comedy movies if we want to lighten things up. And you can get things such as you can rate. Now this rating provides a way of saying rate these or limit these movies based on the ratings from users. And then we can use that as a way to compare to the metrics that we're returning. So not a lot of movies in the 8 category, but if we rank limit by a rating of 7, we can see all the various movies and how they were rated. And then we can see the recommendation score that we generate for those movies. In this situation, we're using the content-based AQL, and this is the score that that method generated. Finally, we can limit even further by language. We may not have any, there we go. And so as you go through, you can explore this just like you'd expect to be able to explore any movie streaming site and get more information on the movies, as well as see how the differences are between the various recommendation methods. So as you cycle through here, it'll update the movie results in live time. And then finally, as you do that, you can also view why the movies were recommended with a graph visualization. You can interact with this and get more information on the users, the edges that are connecting them to the movies, and then the information on the movie here as well. And this graph visualization changes depending on the method that you use. So for example, the graph neural network recommendations are purely based on the outcome of that machine learning experiment. So what we get is the actual edges generated from that experiment. And if we view this in the graph viewer, you get a much simpler view because this is the recommendations for this user. So continue to play around with it. We'd love to hear your feedback if you have any suggestions for improvements or have any novel approaches that you've taken to implementing a recommendation engine with ArangoDB. We'd love to hear about it at learn@arangodb.com. Thank you.